In this video, I'm going to talk about sequencers. In the last video, I talked about oscillators, how to make a variety of different kinds of oscillators, how to control them in different ways. And in this video, we're going to talk about how to make them sing, basically, how to make music out of them. And so we're going to start with the basic oscillator like we did last time. And there's a bunch of different ways you can control the oscillators. So we're going to experiment with that. And what we're going to do after that is we're going to sequence them. So by changing the resistance, we're able to do a whole bunch of different stuff. So I'm going to show you a couple different kinds of sequencers. Here's another one. So this one's the more traditional 8-step sequencer. This one's using a couple different kinds of chips that we're going to talk about. So I'm going to talk a little bit about how they work, a little bit about the theory of the chips we're using, and then we're going to experiment with a bunch of different stuff and see what we come up with. So let's get started. All right, so first I'm going to talk about the materials we're going to use and the tools. I'm going to be using the OMSynth, which is a circuit prototyping tool. So I've got my power supply, there's a mixer and a speaker, output for headphones, and inputs and outputs for different equipment, and then a bunch of control hardware. But you can do all of this just with regular breadboards and some extra hardware. I'm also going to be using a scope, which you don't need, but it's really helpful. For the tools, I'm going to be using wire strippers. We're going to have to make lots and lots of little jumpers. So I've got my solid core wire here. I'm going to be making a bunch of little jumpers like these guys, and my tweezers. And for electrical components, we're just using a real standard array of stuff. We're going to use some LEDs, some capacitors, and some resistors. So here are my resistor values. I'm just using the most common resistors. And if we need in-between values, you can combine them in parallel or whatever. We'll go over that as we go. And for capacitors, we're again using a real standard array of values, just 0.01, 0.1, 1, 10, and 100 microfarad. Today we're going to be using a few different kinds of integrated circuits. So last time we used the 4106. This is a hex Schmitt trigger. So we'll go over this again really briefly. Then we're going to talk a bunch about my favorite chip, the CD4040. It's a 14-stage binary counter, which is basically just a divider. But it can divide all the way up to 4096. So you can do really cool stuff with this. And then we're also going to be using the CD4051. This is an 8-channel multiplexer. And this lets us do lots of really, really crazy, cool sequencing stuff. So I'll explain this in a bit more detail as well. So what I'm going to do first is I'm going to build a couple oscillators, like I did in the last video, the same oscillators. Then we're going to get into the divider chip, and I'm going to show you a bunch of ways you can use that to do cool sequencing stuff. So first I'm going to build the oscillators with my 4106. So now we've got two oscillators here, and we can control the pitch with the knobs. And let's look at those. So we're going to plug in the scope. And there's our audio oscillator. So let's listen to our audio oscillator. So we'll plug that into the mixer. And there it is. And then this is a lower frequency oscillator. And what I'm going to do is I'm going to plug that into an LED. So on the OMSynth here, I have some LED inputs that go through LED drivers. Now this is a little bit fast, so what I'm going to do is I'm going to switch it out for a higher value of capacitor. And there we go. So now we've got a nice low frequency oscillator. And if we look at that on the scope, here you can see it going up and down. All right, so if we take the output of this second oscillator through a resistor, we feed it into the input of our audio oscillator, you're going to hear the pitch go up and down. So let's... So I have my low frequency oscillator here. This is my audio oscillator, and it's feeding into, the low frequency is feeding into the audio oscillator through a 47K resistor. And as you can hear again, that's making the pitch go up and down. Now, we can replace that 47K with a potentiometer. So we can vary the modulation amount. So let's... I can change the amount of modulation at least a little bit. So we're going to take this low frequency and we're going to subdivide it through another chip. And we're going to take a bunch of those subdivisions and we're going to combine them together, and all of them together are going to modulate the pitch. So I'm going to build that really quickly, and you'll hear the effects, and then I'll explain the how and why. And then we're going to go on from there after we talk about the chip, the divider chip, and I'm going to show you a bunch more cool things you can do. So I built the divider here. I'm taking my low frequency oscillator, which you can see blinking there, and it's being divided by 2, 4, and 8. So you can see the divisions of it here. And we can use these divisions to modulate our audio oscillator. But before I do that, I want to show you another thing you can do is we can use it to divide audio frequency as well. So if we listen to this, so now we're dividing our audio oscillator. So that's the main frequency. There's divided by 2, by 4, 8, 16, until it becomes so low. Oop, that's 16. So we can listen to a whole bunch of different subdivisions. So you can use this as an octave generator as well. But what we're going to do now is we're going to take the low frequency oscillator and we're going to use this to modulate to change the pitch of our audio oscillator. So this one here. Here's the schematic of what we're going to build. We've got our CD4040 here, that's our divider. It's got a clock input that's coming from our low frequency oscillator. And then we've got a bunch of outputs here. There's a few more that we're not going to be using. And of course we're going to connect pin 16 to power, pin 8 to ground, and pin 11 is our reset, and then we're also going to connect that to ground. Now if we take division 2 and we feed that through a resistor, we're going to use a 47K, to the base, the charging of our charging capacitor, which is 8.1 microfarad, we'll hear the pitch will go up and down. And then if I change the rate of our low frequency oscillator, you can hear it going up. We can change the offset pitch. Okay. Then let's take 4, and we're going to put that through another 47K resistor. And let's then connect 8. Okay, so if we look at the signal coming from these 3 resistors on the scope, you can see it here. It's a voltage that's going up and down. And when we apply that again to our oscillator, it's going to look a little different on the scope, but you can hear the pitch going up and down. And if you want to change that sequence, you can then plug it to different outputs. So we have all these different outputs to choose from. And you'll hear the melody will change. Oh, it's a really low frequency. There we go. different one. We can raise the rate. All right, so this is really, really basic. There's many, many different ways to do this, but we're just starting with the simplest approach, and we can build from there. So what I'm going to show you next is, this is the most straightforward approach, so I'm going to show you a couple other things you can do to change that sequence, and then we're going to move on to building an 8-step sequencer, which is basically based on this approach. All right, I've added an LED in the mix, and I'm going to add another one here. And we need a few more resistors, and I'll draw all of this in just a second so you can see what I'm doing. I need to move this. There we go. Here's another LED. Alright, so now you can hear that there's a bunch more steps. And if we look at the scope there, you can see that we're getting a more, there's more steps in our pattern here. And if we listen to that again, and then I can change the speed. And then we can try different configurations, see what happens. Now, if we were to use a button, we could make and break certain connections, so let's try that. So you can hear I'm turning on and off different connections, which is changing the pattern. And you can keep doing this. You can keep adding more buttons, more switches, more lights, more resistors, and we're basically combining together a whole bunch of these different divisions in different ways to modulate the pitch of this oscillator. So I'm going to draw a little bit of that for you now, and show you at least how the LEDs are working, and then we'll move on. All right, so here's a really basic description of one of the different things you can do to play with signals. We've got the divide by 2 is going through, let's say this is a 47K and here's a 10K. It's going through both of these and it's making the pitch go up and down. Now we've got another signal coming from the divide by 8 going through a diode. And what's going to happen is when so at each of these, the voltage is going high and low. It's going, this is powered on 9 volts, and so it's going 9 volts, 0 volts, 9 volts, 0 volts. And this is divided by 2, divided by 4, divided by 8. Now when it goes high, that means current is going to go through the diode. Sorry, in this case it's an LED. And it's going to override this. So this, it will actually block out the divide by 2. So only the divide by 8 is going to go through when it's high. And then it will change the pitch to go up. But then when it's low, the current doesn't go through the diode, it just stops. And now the 2 takes over. So this goes high for, let's say, 8 counts, and this is high. Then when it goes low, it starts going up and down with the 2. So I'll play that for you so you can hear what I mean. Here's the divide by 2, and I'm going to take, so here let's listen to the divide by 8. So it's counting to 8, then it's going high, low. So again, here's the divide by 2, but then I'm going to take this LED and I'm going to plug that in. So it's divide by 2, now it's divide by 8. And if we turn it the other way, then it will reverse the phase. So I think this gives us an interesting effect where we have this division, but then it's being chopped at regular intervals. So when we start combining those, then we get a more interesting and complex sequence. So I'll wire one up right now. So I've done that where the 2 is going, but it's being overridden by the 8. And then I've got the, let's see, the 16, but then it's being overridden by the 32. So it's a bit confusing, but the point more is to just experiment. And you can draw this schematic and just copy it, I guess, and try it and see what you come up with. But I've found that this is where I'm getting a lot of the really interesting results, because it sort of chops up the sequence and makes it a bit more of a melody. And that's ultimately what I'm looking for, is noise and a little bit of melody. So this is really, this chip, the 4040, is what I'm going to be using, or what I do use for lots and lots of projects, and for everything else I'm going to be talking about in this tutorial and the next, I'm going to be using this chip. So from here, I'm able to get all kinds of interesting combinations of rhythms. You can get sub-octaves. I use it for clock dividers. So maybe I have the divide by 4 is clocking a drum machine, while the divide by 2 would be clocking a sequencer. So there's tons of uses for this. So I recommend that people really get familiar with this chip. So what we're going to do now is we're going to move on to the 8-step sequencer. Which is here. It's wired up to a bunch of stuff. So I'm going to tear this down and build this up from scratch and walk you through the parts. There's a bunch of parts here, and there's a lot to go over. I don't go into any excessive detail with any of these chips. I really recommend that people look them up and do a bit of reading on your own. We're going to be talking about multiplexers, more about the divider, and I really don't have time and the resources to really explain these in great depth, but there's tons out there that you can read. So to make our 8-step sequencer, we're going to use the chips we've already put on the board. So that's the 4106, that's the Schmitt trigger, and the 4040, that's our divider. And we're going to add 2 multiplexers. These are 8-channel multiplexers called the CD4051. And basically what these, what a multiplexer does is it has 8 inputs and 1 output. You can also configure it to be 8 outputs and 1 input, 8 inputs, 1 output, whatever. You can do it both ways. And then you have 3 data channels, and you send logic signals to those data channels. And the configuration of these will determine which way the signal goes. So I'll draw that out real quick. So hopefully it'll make a bit more sense. Okay, so we've got 8 inputs and 1 output. And then we've got our 3 data pins. And we're going to send logic signals to these data pins. Now, our 4040 divider outputs logic signals. So we're going to connect different pins from there to, so we'll say we're going to connect the divide by 2, the divide by 4, and the divide by 8. And what that's going to do is that's going to choose which signal to pass through. Now, what I'm going to do is each of these channels is going to go to a potentiometer. Well, let's draw that differently. Each of these channels is going to go to a potentiometer. So whenever any one channel is selected, it will go to a different potentiometer and pass that value through. And in this case, we're going to send that to our oscillator. And basically, what we're actually going to be doing is we're going to be feeding that back. So when channel 2 is selected, it's making a feedback path through this potentiometer, and that's going to set the pitch of this. And then when channel 1 is selected, it will be feeding that back through, and so on. So for each of these steps, we're going to be able to choose a different pitch. And then we can sequence through and choose the different pitches. Now, these don't have to be potentiometers. These could be light sensors. They could be, as we did in the beginning, they could be avocados that are giving resistance. They could be touch sensors. There's any number of ways that this could be configured. They also could be scanning at audio rate. There's a lot of different ways this can be configured. But the most sort of traditional one is what we're going to set up with the 8-channel sequencer. Now, a quick note about the logic. This is using binary to choose the paths. So if you're not familiar with that, I'll just show you really quickly that we've got 3 different data inputs that can be either high or low. So if they're all low, then that means that your output pin is going to be connected to 0. So there's 0. Now, this is in binary, that's 1, so now it's going to be connected to 1. That's 2. Then we've got 3, 4, and so on. You can look up binary. But what you can see here is the different pattern of high-low signals going to your data pins, which are these 3 here, is going to determine which of these channels will be routed to the I/O pin. So what we're going to do is we're going to set up a sequence where it will count in binary from 0 to 8 and then loop. And so you'll get a scrolling sequencer. And luckily, that's exactly what the 4040 does. It counts in binary. So here's just before I start building, just to show you again, this is the circuit. So we've got our oscillators here. We've got our audio and our sub-audio oscillator. The sub-audio is clocking our sequencer. Then we've got our divider here, the 4040. And then we've got 2 multiplexers. One of them is for routing the resistance in the feedback loop to the Schmitt trigger, and then the other one is just to turn the lights on. So it's a bit of a hassle to wire up 2, but this makes it a lot easier to understand what's going on. So, and then you can see, so let's stop the sequence, and then, whoops, that one got unwired, so let's wire that back in. There we go. Okay. So you can see as I change the resistance on the potentiometer, it's changing the pitch. So let's choose a pitch that we want. There we go. Now let's advance to the next step. We can choose another pitch, choose another pitch, and just keep going. A little lower. Okay, anyway, you move all the way through, and then you can turn the sequence on. And then we can change the rate. We can make it really fast. And then some really cool tricks you can do is, because it's binary input, so you have your control A, B, and C, you can feed them different bits from different places, and you can make strange patterns. So, but I'll explain that a bit more once I'm done building. So, oscillator, divider, multiplexer for the potentiometers, multiplexer for the lights, and then some control hardware. So I'm going to build that now. So here's the sequencer. You can see it's scrolling across. We can turn up one channel. We can program different melodies. We can change the rate, make it go slower, make it go really fast. And then if we want to just program one note at a time, what we can do is we can go to the clock input of our 4040, and first what we're going to do is we're going to pull it low. So this is the clock input, putting a resistor to ground. And that's just so when nothing's plugged in, it won't get noise, because you could see when I did that's noise, which can be cool, but that's not what we want. So we pull it low, then we can take a jumper, plug it in, and then touch it to power. And that will advance one note. Now you can see it's a little noisy, and that's, I think we should be able to fix that by putting a capacitor to ground. So I put a 0.1 microfarad. There we go. And that just removes high frequency noise that's making it jump through the steps. So now I touch it, it goes one note, I can tune it. Let's turn the volume up. Touch it again, there's another note. You can see I'm still getting a little bit of jumping, but that's alright. And maybe we want to increase our range a little bit, because that's a pretty high frequency. So let's replace that 0.1 microfarad with a 1 microfarad. Alright, so now we're going to take the clock input again. This is the clock input to our 4040, and there. Or you can play with other values as well to get different ranges. Okay, so we've got our sequence running, and now we can play with a bunch of other things. So we have the sequence, which is coming from our binary counter. So the outputs of the binary counter are plugged into the data inputs. But we can connect those data inputs to other outputs from our 4040. So let's do, let's see. There we go. So now I've taken a different bit, one of the divisions. So let's get our 4040 sheet. So I took output divide by 16, and I plugged that into data bit V. Again, as I keep saying, I'll provide the schematics so that you can look over those. But let's try one more, and let's plug that to a different one. So you can see we're getting a different sequence here. So it's not just scrolling across. Now what I'm going to do is I'm going to make another oscillator. And I'm going to plug that into this potentiometer. Let's see, there we go. And I'm going to take the output of this, and I'm going to plug it, let's see, oops, let's try a different value. Okay, so I'm going to take that oscillator that I just made, the high frequency, and I'm going to plug that into the output through this capacitor, and now I have a harmonically tuned oscillator. So I can go one step at a time. So there you go, and then we'll go to the next step. Oop. Okay, that's one of the tricky things when you have these bits connected. When I hit one step, it's going to go somewhere crazy. So let's unplug those, and now when I advance, it'll just go one note at a time. Okay, so let's go back to our oscillator. So that's it for the sequencer. I'll do a couple drawings of what I've built, but this is enough to play with for a long time. You can play around with making different sequences like this. We can take high frequency clocks like our original clock and plug that into one of the bits and get other interesting effects. We can turn the clock up really fast, and you can see we're getting these cool strobe patterns. So there's a whole lot here to play with. One of the things that's really cool about the sequencer is that you can turn this into a resistance sequencer. So that's where it's going one channel at a time through different resistances, and that lets us do stuff like we did earlier. So I've got this now old avocado. And I can take my signal and I can plug it through. Let's remove this. And when it gets to that step, so this channel we can make just a resistance. And then the next channel we can make a different resistance. So let's use a light sensor. Here we go. So then this channel will be a light sensor. And then when I turn the clock back on, let's do it here. So this channel is the avocado, this channel is the light. And we can make another one. So then I'll put a light sensor in this channel. So I'm able to put whatever I want in these different channels. And so I could have and then I can of course mix up the sequence. There, it's the potentiometers. But I could also turn these into voltage dividers. So, and I would do that by taking all of these potentiometers, and I would run one side to the negative, one side to the positive, and then the output is a voltage. And as I turn the potentiometer to the left and right, it will move between the low voltage and the high voltage. So each of these can be an individual voltage that I send out of this multiplexer. So this can be a sequencer that you can use to control your analog synth, whatever. Or you can just configure it like I showed before, so it's just resistance. So you can do a lot of different things with this. You can set it up in a lot of different ways. And then you can play with the sequencing in lots of different ways too. And once you start playing with CMOS, there's a ton of things you can do. And another thing that I almost forgot to say was that you can also play with how you send those bits. Similar to how I was, to what I was explaining before, where you can use the LEDs, and that will send a signal that sort of dominates the other signal, but I'll just show you. So the sequencer will run normally, so it's going across. We've got some light sensors in here. I'll change. And then we can take a signal and run it through an LED, and I'll plug that into one of the bits. So every once in a while, this signal will come from one of the lower divisions, and it will set it into a new pattern. So it'll run normally, and then this signal will go through the LED. So there's a lot of different ways you can configure this if you want to get different kinds of patterns. So you can see as I remove the LEDs, or even as I flip them, it's changing the patterns. And then I can, of course, change. These are the different divisions for my 4040. Yeah, so this is probably all a bit confusing with all the wires here and everything. But I encourage you to look at the schematics, read about these chips, the CD4040, CD4106, and oops, the CD4051. But yeah, the point of this is really just to show you how I put it together and kind of give you an idea of some of the things that you can try out and an idea of how it sounds too, because I think that it can make some pretty cool sounds. So again, look in the description, and I'll include links to schematics and instructions. See you next time. See you next time. See you next time. See you next time.